Good morning everyone. Welcome to the One Problem Per Day portal. This question will be published on Wednesday and this will be on 26, 27, 28, 29th of January. Okay, so this question is a very short question because the rest part of the question was related to thermal physics and so on, so I did not include that. So now let us start with this one here. This 7 marks, I'll start this timer here. Okay, outline the conditions necessary for SHM to occur. What is the condition? The same question has been repeated every time. Acceleration proportional to displacement. First condition. Second condition is direction of acceleration vector is opposite to direction of displacement vector. Right? So this is what is the condition, right? And then the next question: a buoy floats in a vertical tube and generates energy from the movement of water waves on the surface of the sea. When the buoy moves upwards, a cable turns a generator on the seabed, producing power. When the buoy moves downwards, the cable is wound in by a mechanism and generator when no power is produced. Okay, when it moves upwards, there is a power. When it moves down, power is 0. Okay, so why I am writing it? Okay, because whenever you have such kinds of statements, there will be some question related to it. Okay, every statement in IB papers are very important. You need to know this. Now this is the kind of wave which is being generated. Now look at this. Now I take the center here, draw a line here like this, which passes through the center here like this. What do we see here? This appears like a sinusoidal wave, perfectly sinusoidal wave. See, it is a downward pulse over here, this is an upward pulse over here. So it looks like this over here, right? So therefore it's a symmetrical pulse, because when I see directly I won't get it. So we draw like this over here. So any problem related to waves, first look at the symmetry. Okay, that's one of the shortcuts which you need to understand. If you get a symmetry, then everything is solved, almost it's solved. Okay, then the most of the buoy is assumed to be simple harmonic. Okay, then a wave of amplitude 4.3 meters and 4.3 meters is the amplitude, and amplitude and wavelength 35 meters. Lambda is given with the speed of this is also given. Calculate the maximum vertical speed of the buoy. See, when V and lambda is given, you can find out the value of F, and that is what is required also here. Okay, every problem you take, if at all in a single problem, if V and lambda is given, somewhere you need to find out the frequency. Okay, even if you do not know how to proceed further, first thing is whatever is given, find out the relative values only. So frequency will now be equal to V by lambda, which would be 3.4 divided by 35. Okay, and then what is this value? Let us calculate this value here. Don't just stop at this moment. So just understand why are we doing this. Okay, now this is 3.4 divided by 35, which will be 0.0971. 0.097 hertz. Okay, even though you do not know how to proceed further and you are stopping over here, out of these 3 marks you will definitely get 1 mark over here because you calculate a frequency. Next is to find out the maximum vertical speed. The maximum vertical speed of a particle executing SHM is given by V max is equal to A omega, where A is the amplitude, omega is the angular frequency. So if you know frequency, you can determine the angular frequency. Amplitude is already given to you, 4.3 multiplied by 2 pi multiplied by 0.097. Okay, you got all the values. Now let us substitute this to get the final answer. Let us go back, take it here. Right, now we have 4.3 multiplied by 2 multiplied by 3.14 multiplied by 0.097 will give you 2.619. I'll make this 2.62. So this should be 2.62 meter per second. So what is the question here? The question is calculate the maximum vertical speed. We have found out this here. Next, sketch a graph to show the variation with time of the generator output power. Label the time axis with a suitable scale. So what is the question? Now time axis is given. We have never found out the time anywhere over here, but we can always find the time. How do you find time? See, this frequency is given to you, so you can calculate the time period. Time period is equal to what? 1 by frequency, which is 1 by 0.097. which should now be equal to, how much is it? So this should be, now let me cancel this, 1 divided by 0.097 comes out to be around 10.3 hertz. 10.3 seconds, or not hertz, 10.3 seconds. Okay, why do we need this? Because we are in a graph over here, so definitely you need this. Okay, so this graph is for 2 marks. I still do not know what to do here. Okay, so what I do is, first let us see what we can solve. 10.3 seconds, so this could be one time period, 10.3 seconds. Okay, the other one could be here, this could be how much? 20.1 second, 20.6 seconds, 20.6 seconds. Okay, like this we can try here. Okay, now it's asking you to find out what is the output power. Now how does the output power change? See, when this is a sinusoidal wave over here, output power should also be a sinusoidal wave. Now what does it say? Somewhere we have written here, right? When it moves upwards, there is a power. When it moves downwards, there is zero power. So what we do is, if it is a sinusoidal wave, then we will write it like this. When it moves upwards, see, half of the wave it moves upwards, okay, and half of them it is completely downwards. So therefore you should get a power like this over here, where there is a power over here. Initially when it moves upwards, it goes to the maximum one, maximum power is seen, and when it starts coming downwards, the power completely reduces to zero. It keeps on coming gradually downwards, and then after that, when it's going completely downwards, this becomes completely zero, and then once again at this point it again rises like this, right? Here it is zero. So you get a wave like this over here. If this is 10.3 and this is half of it, mention this also. This would be 5.15 seconds. This is also mentioned. So therefore, this is what is being required over here. Okay, we have drawn the graph also. Right, so we have come to an end to this question. Thank you friends for watching this. Do like, share and subscribe to my channel for more such updates. So this will also be an encouragement to me, and let me see, okay, whether I can always try to keep this channel completely free of cost for everyone. Thank you.